Hello, folks, and welcome to Rational Science, directly from Frankfurt, Germany. Today I'm going to be talking about the semicircle. But before I get into the semicircle, I want to touch upon a couple issues related to extinction. Okay? And why don't I start with this? I'm going to show you a little picture, a little movie, an old movie, and I want you to tell me what you can imagine was different from those days to the days in which we live today. And this comes from the end of the 19th century. This is from 1897. Okay, I want you to look at it and tell me what's different between what you see there and what you see today. Okay, here goes the first one. Okay, so take a good look. That was then. Okay. And the question is, if you see something, all the things that you can imagine that were different, okay, from what we have today. Okay. Now here, what comes next is 10 years later. Okay, and the same thing. The question is, what do you see that's different from what we have today? Okay, all the things that you can imagine, that you can see there that are different or that you think were different those days to our days. Okay. Nice pictures, huh? Okay. Hopefully you got some ideas what was different then from what it is today. And I was focusing on one specific thing, and that's this one, that there were no traffic lights in those days. Okay, here we have from 1937. You know, they just started putting some of these traffic lights out there. They had the traffic lights all the way from 1914, and you know, they put some here and there in the cities and some of the big cities, some of the big intersections, but it wasn't widespread. In fact, the lights did not become popular until after World War II. Okay, so that was like after 1945. You had all these other, they were known as semaphores on the street corners and only on the busy streets. Okay. But there were other things that were very different than today. And here's same test. Okay, I want you to look at this and tell me what you think is different from today. Let's see if you can pick up on it. Okay, here it is. This was then, in the old days. Okay, this is in the 1930s and the 40s. Okay, but here it starts. Okay, this 1900 to 1910. Okay. These are the people in those days, 1910 to 1920. Okay, even the kids. Okay. Anything come to mind that was different, obviously different from what we have today? Okay. Well, let me show you what we have today. See if you can figure out immediately what's different. This is today. Yeah, there was a time that people didn't wear face masks. Can you believe that? Yeah, I know you might think that I'm bluffing, that I'm leading you on, but no, there was a time that people did not use face masks. And so things change over time. You know, it's like surrealistic that we'd go back and find people without face masks. Okay, some other things change. One of the biggest changes in the 20th century, related to extinction again, is this country called China. Okay, and here's what China looked like in the early century, 20th century. Okay, These are 1910s, 1920s. It was a very backward country. Okay, so it had a lot of growth potential because it was so backward. Okay, and you can see how people lived in those days. And if you compare it to today, here's what China looks like today. Some of the big cities. Okay. Okay. Changed quite a bit, huh? And most of that change, in fact, happened in the last few years. What do you think of that? Big change in China, right? In fact, one of the big worries today, especially of the Western world, is this, the fact that China is growing its military. In fact, it was quite popular these days on the news because there was a meeting between the people in the West, the United States, and the people in the East, the Chinese. Okay? So there was a big talk about different things of mutual interest. Okay? And so this issue is very relevant today. China has grown quite a bit, grown quite fast. I like to say that China is the motor of the world, in a sense that it's thanks to China, a lot of countries are growing or still have growth because they sell and buy from China, so there's still economic activity. Okay, and you can see this in trend. Here's a trend. This is the gross domestic product for China in the last 10 years. You can see how it's growing. Okay, and is this reason to be scared? Should we be worried about this, or should we celebrate and say, hey, that's great? You know, Chinese are becoming richer. Compare that against the U.S. This is the U.S. trend. It looks like it's going in the opposite direction. Okay. In fact, it's had a couple bad years. What was it, 2007, 2008, and then 2020, that big last one there. Okay. So the United States is not doing as well as China, apparently. Okay. Again, should you be worried about that? Well, some people are. Here's an article that came out this week, and it triggered me to look at this, okay? And that's a senator from Arkansas. His name is Tom Cotton. He's a Republican. He's a, you could say, a conservative, right-wing, et cetera, okay? And the title of his article was, "What the U.S. Must Do to Beat China." Is this an issue we have to beat China or something, East-West versus West? Or is it maybe to work together and come up, you know, in parallel? Is there a way to stop China? That's maybe a more fundamental question. Is there a way to stop China? Okay, and here's what came out in one of the articles that followed up on this, and then this has to do with the meeting that they had in Alaska for 3 days, the Chinese with their counterparts in the U.S., the State Department versus the Ministry of Foreign Relations in China. It says the Biden administration has cast the U.S.-China relationship as what? The biggest geopolitical test of the 21st century. Okay? And lawmakers in both parties agree and are pushing the Biden administration to craft a comprehensive strategy to counter China's global rise. Is it possible to counter China's global rise, or is this inevitable? I mean, China was so far back that whatever new technology came to their hands, they could, you know, suddenly leap the great leap forward, leap hundreds of years, kind of, they could jump or skip a lot of steps that other countries had to go through because they just adapted the technology, implemented it, and suddenly, they're up in the air. They're much richer, they can produce more, they can sell more, they're expanding, okay? And so the question is it possible to stop China from growing, okay, economically? And another question parallel to that is, do we want to stop China from growing? Okay? One, is it possible? And the other one, is it desirable? Okay? Okay, and it's better to look at this graph. It gives us a better picture of what's going on in China. Okay, and I like this graph a little better. Okay, and it shows that China's GDP grew, but it's been coming down now for quite a few, 15 years approximately. It's coming down. Okay, and especially if other countries don't grow, well, China's not going to grow either. Okay. And here's the U.S. GDP projection for the next 10 years. And the question is whether these are just an extrapolation of past trends. If this is real, if this is what's going to really happen, or is this just the fact that they're extrapolating, trends for the sake of it? Okay, so is this real? My guess is that this is just an extrapolation. They just, well, there's this curve and we're going to continue. You just saw the curve now. Last year, 2020, GDP went down. And now it's going to continue in that slanted curve upwards. Is that what we can expect in the next 10 years? And my guess is not. For the United States or for China. Okay, I think China is also coming down in the sense that their GDP is gonna, their growth rate is gonna diminish as time goes by, and that means that curve is gonna be asymptotic. The GDP curve, the total GDP, is gonna be asymptotic. China grew because it had a lot of growth in front of it, a lot of growth potential, but that potential is now coming to an end. There was a time China was growing at 25% in the 1990s, 1995 and thereabouts. They were growing 25% according to some estimates. And now they're growing, if they're lucky and if they're not lying on their numbers, they're growing only like 6%. Okay, so it's come down significantly. And that's because China's already quite developed compared to what it was. The U.S. cannot grow at the same rate because the United States is almost completely developed. There's not much more that the United States can do to grow, at a rate like 25%. No way. It's already reached its limit. And now China's kind of catching up, and that worries the people in the West, partly for military reasons, but partly because of, the economic influence that China is getting in the world. Okay? Okay. I bring this up because, again, I think that China, at least for me, right, is a measure or serves as a measure of how much time we have on the clock for extinction. And it depends a lot on how much China grows. Okay? If China starts leveling off, we're all in trouble. The United States, Europe, Japan, all the advanced regions of the world are going to be in big trouble. So let's hope that China doesn't level off. But I think it's inevitable. China cannot grow at 25%. Now they're only growing at 6%. And at some point, they're going to be growing at 4, 3, 2, and down the line. And when China grows at 2%, it means Europe and the United States are growing below zero. In other words, they're going to have negative growth. Or they're going to approach zero, at least somewhere near zero. And that's going to be a problem because it's going to be layoffs and lots of upheaval. People are going to go out into the streets, burn cars, They're going to protest. There'll be lots of parades. Okay? That's the way I see it, at least. Okay. Now, a couple gentlemen here put some comments related to the other day. I said, anyone who's got a theory of extinction, that's different than mine. Mine says that there's going to be an economic collapse. And these people say, no, there ain't. Okay, so what do they propose instead? Well, they don't propose anything instead. What they say is that, essentially, man is going to live forever. They can't see, as far as the eye can see, they cannot see how man will become extinct anytime, say, in the next century. In other words, this entire century, we're still going to be here. That's their version, I guess. Okay, and this is what they said. Okay, this is their comment. One fellow says, Bill's view of extinction. I refer the reader to the PDF below, which predicts our world population. It provides various scenarios with ranges from 2.3 billion to 36 billion with an average of blah, blah, blah. Okay. And he's talking about the year 2300. So he doesn't give me a theory of extinction. He just puts out there what he reads. This is what he believes in. Okay. And he thinks there's nothing that, it's going to stop man from continuing to grow, to be alive at least for the next 2 centuries at least. Another fellow, along the same lines, says population follows a cycle linked to the sun. Okay, as the climate warms, population goes up. Yeah, it's the heat, right? Yeah. As the climate cools, as in now, right, the population goes down. Okay, and then he goes out and rant. He says the corrupt Marxist governments have destroyed the cities and people are exiting for the country. Okay, so again, this fellow doesn't think that there's going to be an extinction event of man, right? All the animals all around us are disappearing. Our plants, most of our plants that we use, because we rebreed them, a lot of them we just grow vegetatively. In other words, they're seedless plants. Many of them today are seedless plants. A lot of them have lost their genetic diversity, but we're going to be around for the next million years, according to these folks, because they cannot imagine anything that could kill man. They cannot imagine anything that man can't do. And of course, these people have in the back of their minds that man is not part of the wild kingdom. He's not part of the animal world or the mammal world because we have brains. That's their argument. That's their entire argument. So we can think. I don't know, maybe these two fellows are an exception about thinking, but this is what they have going through their minds, that we're not human because we're something else. In other words, we're not animals. We don't belong to the animal kingdom. Where there's plants, there's rocks, and then there's mammals and other animals, and then there's humans. That's the way they see the world. They don't see us as being part of the animal kingdom. And that's why they arrived at these conclusions. They think that because man can think, he can solve all problems. And again, I keep saying that one of the problems man can't solve is having babies. I said that the other day. I'm not going to go through that again. But yeah, we cannot increase our population, even if we wanted to. Even if we wanted to, okay? The inversion of the population pyramid, human population pyramid, is irrevocable, whether we like it or not. Some people say, well, we don't want to have more children. No. You can't, even if you wanted to, okay? And there are economic reasons. The main reason is, we went from the farms to the cities. And in the cities, you have density-dependent birth rates. And because of that, we simply cannot. With all our intelligence, all our foresight, all our technology, there is nothing we can do to increase population as we were in the past, exponentially. It's going to level off. And the question is, what happens after that? Okay. Yeah, another thing we can't do anything about is aging. But a lot of people think somehow they're going to invent some technology out there that's going to make us live forever, which they don't even realize that that's not desirable either. I mean, if we live forever, that's even going to crowd out even more the young people who come behind. So that guarantees extinction if we live forever. So let's hope we don't come up with that little idea there. Okay. Here's one thing that this fellow can't, with a sun, he can't answer, and that's this curve there. If it's a sun type of issue, you know, that the sun cycles make people reproduce children, he cannot explain that curve, which is the one we've had for the last almost 400 years. You know, we expanded population-wise, right? Exponentially in the 19th century, early 20th century, and now we're leveling off. And there's nothing we can do about that. As you can see, the green line there, it shows that our growth rate, population growth rate, is going down, and by mid-century it's probably going to be down to zero, zero population growth, as it's called, even if things continue as normal, as they are now. Remember, these are just projections, okay? Doesn't mean that this is going to happen, just means that these are projections. More than likely, that's going to level off a lot sooner than what people think, okay? Okay. One fellow says, I have 3 children, 2, and I own 23 acres and grow my own food. I don't ask anything of society but to leave us be. Well, it ain't going to happen. I mean, once the world collapses, the global economy collapses, they're going to overrun your farm, and there won't be 911 to call, okay? So you won't be able to pick up the phone and call 911 and say, hey, all these guys are trespassing. No, it's going to be like in the old days. You're going to be, you know, you're going to plow by day and defend whatever you plowed or whatever crops you put out there by night. Okay? So no one's going to protect you. The big problem after the whole world collapses is protection. No one will have protection. Everybody is on his own. And of course, trust your neighbor at your own risk. Some people say they're going to educate their neighbors to plant and to grow foods. They're going to show them how to do it. There's going to be no time. You're just going to have to fight off everyone who comes into your little garden. And they're going to pick the garden clean. And all you can do is defend yourself as best as you can. Someone's going to survive from that whole mess. It may not be you, but even if it's you, you know, I don't know if you're going to survive for very long or that you're going to reproduce the race again. So yeah, it's never going to happen. Anyways, I always say that anyone who wants to challenge the theory has to do Extinction 101 before he does 102. Everybody's an expert in Extinction 102, which is human extinction. I have yet to find anyone who's an expert on Extinction 101, which is mass extinction, okay? So, you know, tell me how the animals in the past died. My theory is straightforward. My theory says they were all economic collapses, all of them. So the economy of the dinosaurs fell apart, the economy of the synapsids, of the amphibians, when their economy fell apart, that's when they became extinct, massively extinct. What do I mean by that? I mean that, you know, what an animal manages, you know, they have economics as well in the animal kingdom, just like us, no different. It's that, you know, their economy is food. And, you know, we think ours is different, but no, ours is also food. The only reason we produce all this other unnecessary stuff is to produce food, ultimately to produce food. In other words, you produce food to live one more day, to produce more things that help you trade and help you produce more food so that you live one more day. That's how it works. So the entire animal kingdom, including mammals called humans, we all work for food, ultimately. And what happened to these animals when their food sources disappeared, that's when they disappeared. You know, after millions of years, the plants suffer their overturning of their population pyramid, and the plants go away. And when that happens, all the animals that forged the relationship with those plants for millions of years, all those families of plants and all those families of animals that fed on them, the whole thing collapses. And that's what happened at the end of the Carboniferous, the Permian and the Cretaceous and so on. And so I have a theory. I'm saying that when there is no food, you die. Now, I think that's straightforward. Doesn't mean you have to believe in it, but you should be able to understand it unless you have a mental problem, okay? I'm saying no food, you die. Very simple. And what the so-called paleontologists have come up with in the last 200 years is nonsense. They think it's all due to catastrophes. So, hopefully you don't believe in the same catastrophes, don't put the same nonsense when you come and put a comment on this. Some people say that first one there, that there was a supernova, one of the theories out there. Another one says volcanic activity. Another one says there was a comet that hit the Earth or an asteroid. And then, others say that there was a quick climate change and that killed the animals. None of that nonsense, please. Okay. No, you got to be a little more specific. You got to show how climate change or an asteroid kills some animals and left the other ones alive. It's called selectivity. With food, you can do that. When food chain collapses, the other one continues rolling. So food, at least you can understand whether you believe in it or not. That's the type of theory we're looking for. We're looking for a theory that is foolproof, bulletproof, okay? That even man can't do anything about, because if man's human economy, artificial economy, collapses, no one produces food. And so I think that's a pretty good theory that you can at least understand, whether you believe in it or not. Okay, on with our semicircle. Before we can get to the semicircle, we got to start really at the circle, because there were lots of questions related to the circle. Apparently, people cling on to the old days. They were taught what a circle is in high school or college or wherever, maybe elementary school, I don't know. And they just parrot that. They just repeat it. They don't even know what they're saying. And so no one ever analyzed to see if some of these geometries, these figures that we have in geometry, or make any sense. They just accepted it, and now I'm coming in here and saying those definitions are not wrong. They're irrational. And they say, oh no, how can you say that, Bill? Everybody believes in these definitions. Well, I don't care if 100% of the planet believes in them. It doesn't make it right. I mean, the whole planet can believe in the flat earth or in God for all we care. Does that make God and the flat earth right? Or should we try to challenge that theory and say, well, I don't think that's true. I have a different way of looking at things. And if there's something obviously wrong, patently wrong, then you got to modify whatever you learned in high school, in college, or wherever. And that's the case with the circle, not to mention the semicircle. Okay, so here goes. Here's one, and I'll just go with the questions, because essentially it's going to be question driven. They asked me so many questions this week, made so many comments, that we might as well just work with the comments, because that's essentially what it's all about. Okay, and here it is. Here you have this one. He says, circle, as Bill defines, is not an object. Well, I define an object as that which has shape, and that circle there, I think, has shape. So I don't know. He's got to define what he means by object so that we know what he's talking about. But yeah, I defined it as that which has shape, and there it is. It has shape, so it meets the condition that I have in the definition, the specification that I put in there for the word object. So I'm not sure what the problem is. But the second one is funnier. He says the 2D object is a concept. So he does recognize that that is an object. It's a two-dimensional object. There's three-dimensional objects and two-dimensional objects. This is a two-dimensional what? Object, right? That's what he said, his own words. But he says it's a concept. So we have two-dimensional concepts there. Here's does energy have height and width? Does the idea have height and width? Okay. So I don't know how you can have a two-dimensional concept. Do concepts have dimensions? What's the dimension? What are the two dimensions or the three dimensions of mass, for example? How about that? Or intelligence? How many dimensions does intelligence have? Apparently for this guy, none, you know. Okay, another comment or question related to the circle. Okay, and it's three gentlemen here put their notions of what a circle is to them, how they learned it in high school, in college. The first one says the difference between a circle and a disc. Because I showed this as a disc, okay, and I'm saying that this is a circle. That's a circle. And they say, no, that's a disc, Bill. Okay, so what's a circle? And so these people say, well, the first one says, one is a continuous line with nothing inside. The other is a filled circle. Okay? And both are 2D shapes. Okay, and the second fellow says, a circle is the set of points on a plane equidistant from another point. Okay? That gold thing you're waving around is a disc. Okay, another fellow says that, okay? And then the third one says a circle is a two-dimensional shape whose center point is equidistant from any and every point on its perimeter. Okay, so we have a little difference there between, I don't know if you noticed. The first one says it's a continuous line that goes around. The other two say, no, it's a bunch of points. So we already have a difference between these gentlemen. They probably don't have the intelligence to realize that they have a contradiction there. Okay, so I got to point that out to them. The two on the bottom say it's a bunch of points. The guy on the top says it's a continuous line that goes around. Okay, well, the guy on the top is wrong. Not irrational, he's just wrong. I mean, he never learned, apparently never took a course in geometry because, first of all lines in geometry are made of points. From Euclid even to today, all lines are made of points. So he should have known that there is no such thing as a continuous line. Okay, not in geometry. Okay, and the other reason is that the line is really a bunch of locations. It's not even points. The famous word point means location or number. So we have a bunch of locations, and a bunch of locations is motion. So they have locations. They have motion. That's what they're referring to when they say point. And so no, it's not a continuous line. That's the first one. And here we have proof of that, evidence. Okay, these guys like proof and evidence. Here we bring proof and evidence. If I can get this thing up there. Oh, where is it? There it is. Let me put it over here maybe. Okay, here's Euclid's circle. Okay, what was Euclid's circle we talked about the other day? Well, it's a bunch of spokes. That's what it is. A circle is a plane figure, okay, contained by one line such that all the straight lines falling upon it from one point among those lined within the figure equal one another. Well, each line, according to Euclid, ends in a point. In fact, the definition of line that he gives is that a line has one point at each end. So the line that Euclid concocted is made of points, and so those lines, you have to think of them as made of points, and they end in a point. That means that the circle, or the circumference, as he called it, is made of tiny dots. In other words, what are those dots? Those dots are locations, okay? And they're discrete. They're not continuous. So the line that's going around is not really a solid line, not a continuous line. But if you have problems with that, well, you still have good old Stephen Hawking and all the people today. This comes from Wolfram Math World. Says a circle is what? The set of points. These people should learn how to read. It's not a continuous line. It's a set of discrete points. In a plane, what's a plane? Well, hopefully we'll find out in a second what a plane is, okay? To make sure that we understand whether they're talking about just the points or something within the points, okay? Plane that are equidistant from a given point 0 or O, okay? Okay, so it's a set of points, so it's not a continuous line. That's the first thing we got to clarify here. And again, it shows that, these fellows sometimes don't even study geometry and they just wing it. They say, well, it's a continuous line. No, it's not. Not according to mathematical physics. Now, I don't know where this gentleman studied, maybe in a church, I don't know. Obviously, he doesn't know something as straightforward as that there are no lines that are continuous. They're all made of points. And second, they're telling you that it's a bunch of points that, are somehow are equidistant from a center. So we're done. There is no such thing as a continuous line. Okay? And just in case, we have a clarification from Clark University, the people who have put Euclid's Elements, his book, online, and they not only quote him and put the translation, but they also analyze what Euclid attempted to say. Okay, and this is what Euclid said, okay, regarding, or the clarification that Clark University does with this, says, note that a circle for Euclid, right, is a two-dimensional figure. Two-dimensional figure, okay? So really we're talking about a sheet, continuous sheet. That's what a plane is, okay? But in modern mathematics, usually the word circle refers to what Euclid calls what? The circumference of a circle. So Euclid would not agree with the circle that the mathematicians that came after him concocted, which is this notion that a circle is just a bunch of dots at a certain distance from a center. That's not what Euclid thought. He thought he was thinking of a continuous line, but then, they said, well, but the line is made of points. So Euclid was contradicting himself. That's the bottom line. But anyways, the notion that Euclid had is that the circle, okay, the circle is the whole thing, the plane that goes from anything inside his continuous line. And that's not what these people are saying. These people are saying that the circle is really what? The circumference. They're saying that circumference and circle are synonyms. That's what they're saying, okay? So let's get it right. Let's find out what Wolfram says here. Wolfram says that they clarify what a plane is, okay? It says a plane is a two-dimensional, doubly ruled what? Surface, spanned by two linearly independent vectors. That means it's a surface which is spanned. Something is stretching across that surface. That's what a plane is. And they say that circle is a plane. So these people are saying here, Wolfram is saying that a circle is not the little dotted thing, the little wheel, just the outside of the circle, the circumference. Now they're saying it's the plane, it's what's within these dots. That region is what the circle is, because a plane is a two-dimensional surface. And so we have to keep looking at these definitions. What is a two-dimensional submanifold? Because that's the word they're going to use. It says two-dimensional submanifold of three-dimensional Euclidean space. Okay, what's a manifold? A topological space that is locally Euclidean, meaning that if you go sufficiently close to the thing, it's almost flat. What is flat? A surface. Okay, and again, a topological space is a set of X together with a collection of open subsets, blah, 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 blah. What are they talking about? Numbers. In fact, you can look it up. Each one of these definitions, you'll find that they're not talking about physics. They're talking about math. And math and physics will never meet. Math is math, physics is physics, the twain shall never meet. And this is the problem. The problem is that these people try to turn physics or mathematize physics. That's what they try to do since the days of Euclid. But the important thing is that what is a plane? Okay? A plane is a surface. It's a continuous surface. That's the notion. And they say that a circle belongs to planes, therefore it cannot be just a dotted perimeter. Okay? I want to make sure that those points are clear, okay? Okay, but when all else fails, this is what you got to answer. If this is a circumference, bunch of dots going around, right? And that is a disk, according to some of these people, then what in the world is a circle? I mean, if either the circle is a synonym of circumference or the circle is a synonym of disk, what other option is there? Which one do you want? Sometimes they say it's a plane, meaning they're referring to the disk, and other times they say, no, it's just the little dots on the outside, on the perimeter, in which case they're talking about the circumference. What do we need the word circle for if we have the word circumference for one and we have the word disk for the other? Okay, so this is where we're at. It is an irrational definition what they have for the word circle. It's an irrational definition because they can't make up their minds whether the circle is just the dotted perimeter or whether it is the disk itself. And they do have to clarify that. I mean, if we're going to use these definitions consistently, if we're going to apply them to geometry, then they should tell us, you know, whoever's going to give the presentation, right? The geometer or whatever, he's got to tell us which he calls the circle. Is it the circumference or is it the disk? And as of today, we have no answer to that question. They want both. As always, they have all these dualities in mathematics. Okay, so let's go on with the, there's also, to confuse things even further, it's not only those dots that are out there just static there, it's also that a circle is something that's twirling around. It's the famous figure of mathematics is a dot that's moving around in circles. Okay, so if you roll an apple at the end of a string, they call that a circle. Okay, it says equivalently, this is out of the Wikipedia, says, it is the curve traced out by a point that moves. So they have what is known as a dynamic figure. That's the other version of the circle of mathematics. So they have both. They have one where all these dots are just out there and the other one where it's an apple going around in circles. Okay, and so here we see other people trying to define or give us their notion of what a circle is. One fellow says, a set radius swiped around the reference point, restricted to a plane, a circle can be drawn. Well, again, it's similar as the one on the left, because what the fellow says is, this is how you draw a circle. So who cares? I want to know what a circle is before you draw it. What do you mean by circle? I mean, if you're going to define it. Otherwise, you know, finish the circle and call me when you're finished drawing it. But this person's just telling you, you know, how to draw a circle. Another fellow just gives you an equation. He said, this is a circle. And he gives you some kind of equation. There's another fellow who also gives you an equation. But see, the interesting thing about that other equation, the one that's got the powers of 2, right? Squared. It means they're talking about a surface. They're talking about, if that's a circle, then they're talking about, again, a plane. They're talking about, they're saying the circle is the whole thing. That's within the perimeter of those dots. And then a third guy says circumference, and I guess he copied this from the wiki also because I saw the same thing there. It says circumference. In geometry, a plane curve, plane, you mean like plane? You like surface? You mean like a sheet, continuous sheet? Is that what a plane is? Plane curve, the locus of points equidistant from a fixed point C, called the center of the circumference. Again, you know, is the circumference the same thing as the circle? And then he continues, says the circle is the flat what? Surface enclosed by a circumference. And again, we have a problem because we don't know whether the circle is the circumference or circle is the disk. And until this fellow can tell us that, he can't give his presentation. We need to know what he means by the word circle. And right now, everybody's confusing circle with circumference in one instance and circle with disk on the other. Okay? So once again, I repeat, this is a circle. We point to it and say circle. Okay, now this one is a 3D. I use it for representations only. You can only put a circle on paper, and it's got to be final. It's got to be there already. I can't say, let me draw it for you. No, I don't care. Call me when you're finished drawing it. And then you got to describe what you drew. And if you're going to say that it's just the circumference, and that the circumference is a solid line, when all lines in mathematical physics are made of points, discrete points, which are not points, which are locations, which are really numbers, ordered pairs, that's what they are. So what the hell are we talking about after a while? We don't know, we have no idea, okay, because the fellow has to tell us what he means by circle. And one of the problems there, people say, well, Bill, what use do we have for this? For this disc, your famous disc. We don't care. We don't care what use you have for it. Here we're trying to find out what a circle is. This is what a circle is, okay? And if people don't like this, then they have to tell us what a circle is. And if they're going to define it, it's not a figure. Because in science we do not define objects, figures, things. In science we point to them. Okay, so you point to a circle. Okay, if you're going to define it, then you're talking about a concept, and concepts are not figures. That means it doesn't belong in geometry to begin with. We don't have concepts that are figures. No, it's either a figure or it's a concept. And if you define it, it's a concept. It's that simple. Okay, so what is a semicircle? Let's find out. Well, here it is. Okay, it's half a circle. This is Euclid's version, okay? It's in his definition 18, okay, in book number 1 of Elements. So a semicircle is the figure contained by the diameter and the circumference cut off by it. Okay, so that's Euclid's version. Again, he made his circle with lines. There's always a line between any two lines, so his circle is never finished. It's known as the unfinished circle. Okay, and he says it's a continuous line that covers that circumference. He's wrong there too, because all lines are made of points, discrete points. That means between any 2 points you can fit another one, according to Euclid and according to math today as well. So the whole definition is screwed up. It's no good whatsoever. It's irrational. Okay, and the center of the semicircle is the same as that of the circle. Great. Okay, that's Euclid's version. This is the one from mathematical physics today. This is today's version. Maybe I should put it over here next to Euclid's famous semicircle. Half a circle. That's what Wolfram calls it. That's what a semicircle is. The area, and it continues, it says, the area of a semicircle of radius r is given by blah, 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 blah. Area? What do you mean area of a semicircle? I thought a semicircle was just those dotted lines. Why are you talking about area of a semicircle? So we have a problem, because now suddenly they define it as a bunch of points, but then when they talk about area, they talk about the area of the circle, and they're referring to the circle itself, what's on the inside of the dots, within the perimeter. And you see this when you look up the word cylinder, also from Wolfram. A solid of circular cross-section in which the centers of what? Of the circles all lie on a single line. What is a circle according to the cylinder version? Well, it's a cross-section, a slice of a cylinder. And that means they're talking about not just the outer rim, they're talking about the area within the rim as well. They're talking about that surface. That's what a plane is. Okay, so these people have to make up their mind. They can't keep going back and forth and saying, this is what a circle is, and then they don't use that notion of a circle because they're going to be using this notion, the slice, the cross-section. Okay? So this is where we have a problem with all these people, because they're not using they define one thing, then they don't use it. They say, well, we're going to take a slice of a cylinder and we're going to call that a circle. That's not how you define it. You define it as a bunch of points. What's this nonsense about now saying that it's a slice? It's a continuous surface from perimeter to perimeter, from one side of the perimeter to the other side of the perimeter. Which is it? And of course, they can't answer that question because they say it's both or none. Depending on whether they want to overrule you, they say, well, it's none, you know, so don't attack us. Okay, so here's a little summary of the circle from my point of view. Okay, mathematical physics is the vain attempt to merge mathematics and physics. This started with, at least with the Greeks, not earlier. Why? Because they had a surface, or they had some object out there, some figure. It could have been a cube, also a solid. And they immediately tried to measure and look at the relationships between measurements. That's how this grew. That's how geometry was born. So here they had a figure which belonged to physics, and what they did was they brought math, measurement, units, numbers. They looked at relations, and all that belongs to math. That doesn't belong to physics at all. And you cannot have physics and math and physics. Never the twain shall meet. Okay, and this is where the problem is. That's how we ended up with a religion of mathematical physics today. And that's why we have all this nonsense out there like black holes and dark matter and dark energy and particles at two places at once, because it's a vain attempt to merge mathematics with physics. No, math is not the language of physics. The language of physics is illustration. In the religion of math, phys, right? A line is made of infinite points. That's according to their own rules. This is not me putting words in their mouth. This is according to the horse's mouth. They themselves say that a line is made of points. That's never changed since the days of Euclid. In fact, if you look at Aristotle, he said the same thing. I covered that in the past as well. They talk about motion. For every location, they call that a dot, or they put a dot and they call it a point. And what does that point represent? A location. What are they talking about? They're talking about motion. And that's what a line is. That's why they talk about one-dimensional line. And you say, what do you mean a one-dimensional line? What kind of figure, geometric figure is that? No such monster. You cannot even imagine a one-dimensional line. Why? Because they're not talking about dimensions. They're not talking about lines, figures. They're talking about motion. Mathematics has no use for lines. Mathematics has no use for dots. Mathematics has no use for planes or solids. Is a solid hollow? A cube, when they say cube, are you thinking it's a hollow cube? Or why do we call it solid? It's solid, right? Yeah, these people want to make you think that it's just the perimeter, the outside of it, the surface or whatever. Okay, in physics, no object is infinite. Okay, maybe in the religion of math, object is infinite, but not in science. And all objects are finite by definition. What is an object? That which has shape. Hopefully all shapes end somewhere. Okay, so they're all finite. In physics, the amount of matter in existence is finite. Okay, God does not create matter every day. We cannot turn space into atoms and atoms into space. No way in either direction. And so the amount of matter in existence out there, you know, wherever you go in the universe, the amount of matter is constant. Okay, in the religion of mathematical physics, a point is a misleading term that means neither. It means either location or number. That's what the word point means. So they use the word point because they want to incorporate both notions. Location, which is a concept of physics. We talk about the location of objects, okay? And has nothing to do, you know, the qualitative notion of location has nothing at all to do with math. Math has no use for the qualitative notion of location. That's why they don't use the word location. They always talk about position. And what is position? Well, it's an ordered pair, an ordered triplet, or whatever. It's a bunch of numbers. That's what a position is to a mathematician. It's got nothing to do with you having distance with respect to me. That's why they never were able to define what location is. They don't have a use for such a word. And they don't have a use for the word motion either. They use displacement or, something along those lines. They're not going to use the word motion, meaning qualitative motion, because they have no use for that. Just like they have no use for the qualitative time. They only have use for quantitative time. They have to use seconds and minutes and years and whatever. They have no use for saying before and after. Math has no use with those type of notions, those concepts. Okay? Neither location nor number is a figure. So if a point is location, if a point is number, well, then they're not talking about geometry, because geometry first and foremost is what? The study or the analysis of shapes. So you have to have a shape. And if they're going to start with a point, which is the building block of geometry, and they say, well, what is a point? Well, it's zero dimensional. That which has no part, Euclid said, meaning there's nothing there, because he was referring to location, not to a geometric figure. Okay? So yeah, we have a problem already. Starting point, there are no such things as zero-dimensional points or one-dimensional lines in physics, maybe in the religion of math, math phys. And then the line of math phys is an itinerary, okay? It's made of points. The point is location, so we're talking about itineraries. And of course, when you raise these issues with these folks, they don't like to hear that, because this is what they studied in school, in high school, and college. And so they say, Bill, are you telling us that for 2,500 or 3,000 years we've been wrong? No, you've been irrational. And if it's irrational, you have to challenge it, not accept it on the basis of authority. These people are accepting all this stuff on the basis of authority and tradition. They say, well, this is how I learned in school, and this is what everybody out there believes in, and that's what I'm going to use. Well, yeah, go ahead and use it. I'm just telling you it's irrational because the definitions are irrational. They contradict each other. We don't know what a circle is. And when I challenge these people, the only argument they have is authority and tradition. That's it. They have no other argument. They cannot challenge what I'm saying because I'm saying something that is straightforward. I'm showing them, according to the definitions of mathematical physics, according to the definitions of geometry itself, they have contradictions here. And if they have contradiction, they have irrationality. You can't use those notions consistently, and they can't, and they don't. They don't use them consistently. They just switch over whichever one they need. Whenever they need for the circle at least, whenever they need the perimeter, they use the perimeter, and they call it circumference, circle, whatever they could call it, whatever. They could call it X. And whenever they need the disk, they say circle, disk, or whatever they need to call it. Again, they can call it Y for all we care. We have a contradiction, and so we don't have a circle. And if a semicircle is half of a circle and the circle is already irrational, well, we have an irrational semicircle as well. Okay, just maybe a corollary here, if I get it in there. It's all the way at the bottom. Let's get a little corollary here. Put it on this side. Okay, what's the corollary? The corollary is that the circle of math is not a continuous curved line, okay? Because all lines are made of points, dots, meaning locations, meaning numbers, ordered pairs. So if you're talking about 2D, right? And so the circle of mathematics is not a continuous line. That's the first one I want to challenge, okay? So anyone who thinks that is fighting the establishment, not me, okay? It's made of discrete points. That's the first thing you have to understand. If you haven't learned that, well, you haven't taken your first course in geometry, okay, in school. Mathematics, there are gazillions of points between any 2 points, okay? That's the worldly wisdom in geometry, in mathematical physics. So first learn the basics, okay? The circle of mathematics is not a plane. okay, because they say it's just a bunch of dots that form a perimeter. And then, they always talk about surface and they always talk about area. So you say, well, what do you mean it's not a plane? Is it a plane or is it not a plane? If it is a plane, then the whole disk is a circle. This is a circle, okay? And if you're just going to talk about a perimeter, then you're not talking about a plane. That's not a plane. Okay, a bunch of dots is not a plane. Okay, what is it? It's a ring made of discrete points which are not in touch with each other. Okay, so there's holes everywhere between any two dots in the perimeter. The water is leaking out through all of them. And you can plug it with more points. Just put as many points as you want. I'll put another one in between any of your 2 points. So you can't plug the perimeter of your so-called circle. Okay, it's not a hula hoop made of a single piece. No, it's got all these little dots, okay, that form the circle. And then concepts we define. So if they're going to define a circle, it's a concept. And no, then it doesn't belong to geometry. It's not a figure. Figures, objects, we point to. Okay, let's get on with the questions for this week and comments. One fellow says, if we currently see things as where they were when, then does that mean location is not instantaneous? Because you got to think location is always live, since the ropes are straight and not curving in on an angle from a thing's old position. Yeah, we have to distinguish between location, which is instantaneous. In other words, location is a static concept. The other one is measurement, or what the observer sees, and that is not necessarily where the object was, okay, because it takes time, takes motion for the torsion along the rope to arrive to your eyes. You look at the Andromeda galaxy, light only travels at 300,000 kilometers per second. No slower and no faster. Always at a constant speed, okay? Why? Because the only thing that changes, if we follow the little c equals frequency times wavelength, little c being a constant, it's called a constant, and a constant is what? 300,000 kilometers per second, plus or minus, right? And that's the speed of light. Always travels at the same speed. The only thing that changes is frequency with wavelength. So if light always travels at little c, and something is very far away, like the Andromeda galaxy, yeah, it's going to take some time to reach your eyes. That doesn't mean that when that thing blips in the atoms of your eye and allow you to see the Andromeda galaxy, which is 2.2 million light years away, meaning traveling at the speed of light, it takes 2.2 million years for that light to reach your eye, then yes, you are looking at Andromeda when it was in the past. And that's essentially what Einstein said, and I have to put my hand in the fire for that one for him, okay? And yeah, it travels at a constant speed and it takes time. Okay, so you got to distinguish between location and what the observer perceives. Okay, so that's my comment there. Next issue, fellow says, 0 time is t equals 0. T equals 0 and delta t equals 0 have different meanings. Okay, I don't know if that makes any important, if that's important at all. I think that instantaneous means the limit of delta t tending to 0. No, instantaneous is not the limit. That's what they keep telling people who study math, okay? You know, when you go to college, they teach you about the limits, okay? And that's not what it is. And again, he says infinitesimal in mathematical terms. Now, we don't care about that. Instantaneous means a single frame of the film. That's what instantaneous means. There's no such thing as instantaneous motion, let alone instantaneous time. So T0 belongs exclusively to the religion of mathematics. There's no such thing as T equals 0 in science. Okay, there's either before and after. So whenever you get stuck with math and you don't understand it because math gets in your way, well, just turn it into qualitative stuff and then you'll understand it. Time is before and after, yesterday and today, or tomorrow, or whatever. There's got to be 2 frames in the film. Okay, and so t equals 0 really is equal to location, means no motion, no time. Okay, and there it is. For the purposes of mathematics, it's just the beginning of your number line. That's it. It's the starting point. What's at that point? Location only, because you have t equals 0. There's been no motion, no time. Okay, so I don't know why this is so hard for some people to understand. Instantaneous means a single frame in the movie. There's no motion, no time. I don't know how else to say that. If you don't understand that, well, then you have a little bit of a problem. You don't have to see a physicist. What you need is a psychiatrist. Okay, hopefully people understand t equals 0 is equals to instantaneous, which means no motion. That's what instantaneous means. No such monster as instantaneous motion, like in mathematical physics. They have t equals 0. Okay, well, it says, the assistant will have to say when he felt the perturbation with his hands holding the rope on the other end. I was talking about separating the ends of one rope so that you could compare the speed of separation versus the speed of the torsion along the rope. And the first comment there is that there are no observers in science. So we don't have, we're not talking about what the assistant sensed, okay? That's what I'm saying. Just tie it to the wall, tie your rope to the wall, open the other end, and film it. And then just look objectively at the film, okay? And see if the speed here is the same as the speed there, okay? And there, the next comment he put in there says, this proposed mechanism of yours leads us to say that the rope is not rigid. Yeah, the rope is not rigid because I don't know where you got that word. We never use the word rigid for the rope. The rope is really taut. It's pulled tightly. That's not the same thing as rigid. Rigid means made of a single piece, which is what he analyzes here. And so the mathematical experiment only purports to compare the speed of propagation of a torsion along a rope with the speed of quantum jumping. So we have this bloop, 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 bloop. You know, the atom is expanding and contracting, and that expansion and contracting is what torques the rope. And then the torsion along the rope is much faster because it reaches a farther distance than the distance in the atom just expanding and contracting. And so I put as an example, as an analogy, a gun. Pulling the trigger on the gun is not the same speed as the bullet leaving and shooting outwards. The bullet goes a little faster than the finger on the gun, on the trigger. Okay, and that's more or less the analogy for an atom. An atom, the pumping of an atom is not nearly as fast as the torsion along the rope. And again, I don't know how else to put that to people. Hopefully they understand. My God, sometimes. Okay, let's continue. Here we have another fella, or I think it's the same fella. Bill, let's start defining the word tree. Because it doesn't have a unique meaning as you think. And he goes into defining the word tree. This fellow is confusing the word tree. When you look at just one tree and you point to it and say tree, could be a sycamore tree, could be a fig tree. We don't care what tree it is. There are gazillions of trees out there. Tree is a category of plants. As a category, it's not an object. We're talking about when you point to a tree, that's the object. Okay, so please do not confuse the category with what you're pointing to. My God, these people have really mental problems. I have to believe these people, really have to see a psychiatrist. They can't tell the difference between a category and the thing you're pointing to. It's just mind-blowing. Unbelievable sometimes. Okay, another fellow, he goes in there and he says, what? There's a huge difference of an image on a screen. Yeah, image on a screen is an object that does not exist. Okay? Doesn't exist. The object does not exist. Versus a tree we can see and touch that has 3D properties in a 3D locational environment which has weight. Yeah, that's an object that exists. So one is an object that does not exist, a 2D image on a screen or on a piece of paper, or the one you're imagining, okay? You know, that tree, that rock that you were thinking of, that's a rock, and the word rock refers to an object. And you say, but that's the one that I imagined. Yeah, it's still an object. You know, when you say rock, we all imagine some kind of stone out there, you know, something, something. It's got, you know, when anyone mentions the word rock, well, this guy imagines one type of rock. Maybe it's yellow. The other guy imagines a gray rock. The other one a blue one. Who knows, a brown one. We all imagine our rocks, different shapes, different colors when someone mentions the word rock. But everybody imagines a shape when the guy says rock. You know, what are you thinking of when the guy says rock? He says, think of a rock. What are you going to think of? Well, you're going to think of a rock. You know, it's got to have shape. And if it has shape, it's an object. So, and the word rock always refers to an object. The one you point to, not the category of rocks like this fellow here. Okay? So he says, what is an object? Yeah, that exists. And what is a 2D object that does not exist? I filled in the blanks there for him. Okay? So are you defining existence or object? What do you want to talk about? You want to talk about exist or you want to talk about object? Make up your mind. Because this guy is distinguishing between what exists and what doesn't exist. He's not telling me anything about the word object. He's just saying that these objects exist and these other ones don't. These other objects don't exist. That's all he said. He hasn't said anything about the word object. He's got to define the word object, and he's got to do so in a way that he can use it consistently. In other words, a lot of these people go out there and they look for a definition, they put it in there, they don't even analyze it. They don't even know what they wrote. They have to take a reading comprehension course because they don't know what they read. They just copy and paste. There it is. And so the guy doesn't know what he put in there. He doesn't know what he's defending, what he's attacking, because this guy's attacking the word exist, not the word object. We're talking about the word object. What is an object for the purposes of physics? And an object is that which has shape. And physics only deals with objects that exist, not with objects that do not exist. That doesn't mean they're not objects because they don't exist. Okay? Okay, another fellow. And he says the following. He says, one thing you can define with complete negation is no thing. The absence of all things. And I guess something is nothing, nothing. Right? Is that what he means? We're just going to put negations. You know, a horse is what is a horse? Well, a horse is not a dog and not a cat, not an elephant. It's not a tree. Are we going to put all the knots that a horse is? Is that a definition of a horse? Is that how you're going to define it? Okay. So what is energy? Well, it's not intelligence, it's not mass, it's not force. We're going to go through all the words that it's not. What is this, a guessing game? Now, you can't use negations because negations are synonyms turned around. They turned into antonyms. And this fellow believes that because he's got an antonym that he defined the term. The answer is no. An antonym is no definition at all. So no, nothing is not a no thing, because then a thing is a no thing. No nothing. Okay, next one. My God, some of these people. Here's a fellow says, on the other side. Give me a second here. All the way down at the bottom. Okay, the fellow says, describing flat as lack of thickness is wrong. Wrong? According to whose religion? Yours? Something has thickness. Well, in order to understand what you're saying or find out if it's wrong or right, it'd be nice if you define what a thing is. In what way do you define the word thing in such a way that it includes thickness and that you can use that definition consistently? And so, no, things do not have thickness. Okay, things have shape. That's the only universal property of things. Some things have thickness, some things have weight, some things are 3D. We have all kinds of or types of things. Okay, so no, a thing is not that which has thickness, a thing is not that which has weight, and a thing is not that which moves, has mass, energy, or any of those things that mathematical physics has invented. Okay, here's another issue, another question. Fellow says, why is there movement at all? Totally irrational question. Okay, so anyone who asks that question is like asking, why are they objects? Why are there objects? And the answer is that's an irrational question, because you're introducing a question of philosophy, which answers questions of purpose and reason, and you're phrasing it in the context of physics, which deals with objects, causes, and mechanisms. So the answer to why is there movement at all, the answer is always the same, because God wanted it that way. Okay, that's why there is movement. God set everything in motion. He's the guy who created everything. So why are there objects? Because God had a headache. And why is there movement? Well, because God took an aspirin and the headache went away. That's why. The why questions have to do with philosophy in this context. When you're talking about reason and purpose, you're talking about philosophy, not about physics. That's why it's an irrational question. Okay. Okay, next one. Fellow says, the most accurate, descriptive model is the quantum model. Whoa, is that what science is about? Is that what physics is about? Describing? I describe a chair, and that's science, that's physics. You know, here I measure this chair. It has 1 seat, 2 armrests, and 4 legs. Does that make you a scientist? Does that make you a physicist because you described a chair? So this person thinks that quantum is the most accurate scientific or physical theory because it describes. No, descriptions are not part of science. In science we don't describe. In science we have to explain. You got to explain something. Okay? Okay, and so on the other side again. A second here. Another issue or comment on this? No, just wanted to say here that there's this professor, Donald Simonek. He's from Lock Haven University in Pennsylvania, emeritus, by the way. And he says, science doesn't explain, science describes. And that's what most people out there believe. And the reason they believe that is that mathematics can only describe. And so for the last 400 years, we have equated science with math, when that's not the case. Meaning math, science meaning physics, right? So they're equating physics with math, when physics has absolutely nothing to do with math. Mathematics has nothing to do with physics. Mathematics is just a descriptive language. That's all it is. It just describes. And science is not about describing. Neither is physics. Physics is about explaining. You have to explain something. Otherwise, if you describe a chair, is that science? Is that what quantum does, just describe? So no, science is not about describing. Science is about explaining, because that's where you have to break your brains. That's where you got to, burn some calories out to some gray matter, okay? And just in case, for those who are wondering, here's the difference between an explanation and a description. Okay, explain the causes or reasons, in the case of philosophy, underlying a phenomenon. Okay, and second notion of that is how or why a consummated event happened. An explanation deals exclusively with the past. Science only deals with the past. We have to explain consummated events. We have to explain how something happened, what caused it to happen. That's the issue. How a magnet attracts another, okay? So when you say, why does a magnet attract another, you're really saying how, what caused it. Okay? That's what physics is about. Not saying it did. That's not science, that's description, that's mathematics, okay? And then they give an irrational explanation for why it did or how it did it. Yeah. So, and what is a description? It's just a listing of properties of a physical object. In science, we use adjectives to describe and adverbs when we want to qualify or characterize motion. Okay. Next issue, fellow says, get it up here. Got to get faster at raising these things up there. Quantum mechanics has many flaws in its physical interpretation, acknowledged by physicists, despite what Bill says. Well, this fella's putting words in my mouth, okay? I've always said, and here's proof, evidence, okay? Here's what I always put up there. Feynman, I think I can safely say that nobody understands quantum mechanics. Niels Bohr said it. Steven Weinberg, Nobel Prize, he said it. Werner Heisenberg, they all said the same thing. No one understands quantum mechanics. And so I'm repeating what they're saying. When I say this, people like this gentleman here, they say, well, you didn't understand really what they meant by that. I didn't understand what they meant by that. They're saying that they don't understand, all of them say it, and these people say, well, if they didn't understand, how can we have technology? That's essentially their answer most of the times, okay? They say they do understand, for otherwise you wouldn't have that computer you're typing on. That's the kind of answer they give you, okay? So here are the issues, okay, for this gentleman to answer, okay, if he's smart enough, which I doubt, okay? These are the issues he's got to answer, okay? First of all, he's using this statement. Let's put that up there again so we can compare it, okay? Get rid of Feynman here. There we go, see, get rid of them. He said, has many flaws. Why does he use that language? It's not that it has many flaws, okay, buddy? It's that there is not a single rational explanation, a single rational physical interpretation in all of mathematical physics, in all of quantum mechanics. Why does he says it has many flaws? It doesn't have many flaws. There's not one physical interpretation that is rational in all of mathematical physics, and that's what I challenge this fellow to come up with. Just one explanation that is rational, okay? By rational, I mean that you can make a movie of it and you can understand it by simply staring at the movie, okay? And so here are the issues, because these people, when you say, hey, here you have Feynman saying that, no one understands quantum mechanics, they say, of course they understand. For otherwise, you wouldn't have a computer you're typing on. That's the kind of answer they give you. So here's the issue to you, okay? Do the mathematicians understand or don't they? Can they give you a physical interpretation for the subatomic world or not? Can they draw a hydrogen atom? Okay, and justify it. I mean, does the electron bead, how does it stand always in an orbit? Why does it fly away spontaneously? Why doesn't it fall to the nucleus? That's what you got to explain. So it's not just saying, yeah, I can draw a hydrogen atom. Yeah, some idiocy that you might draw. That doesn't mean that you can justify it. In fact, they explain electricity with the planetary model. They explain, quantum jump with a planetary model. They explain ionization with a planetary model. So please justify the planetary model. That's what you got to justify. And what you got to justify, why doesn't the electron fall to the center, to the nucleus, or why doesn't it spontaneously fly away? If you can't answer that question, you don't have a rational hydrogen atom, and you can't even start your presentation. Can anyone in mathematical physics, in mathematics, can they make sense of a particle being at two places at once? What sense does that make? That came from the mind of an idiot. That's what it's known. It's an idiot. That's the correct word. Don't tell me that it has many flaws. Tell them that they're all a bunch of idiots. That's the correct language to use. I'm being polite here. I'm just calling them idiots. Okay? Does the fact that we have computers prove that a particle can be at two places at once? Okay, that's the theory that these people are giving you. So don't tell me it has many flaws. It's all flawed, and it's not flawed, it is irrational. That's what it's called. And this wishy-washy guy gives us the answer. He says, has many flaws in its physical interpretation. Why does he use the correct language and say it's all irrational? Because otherwise his religion goes down the drain. That's why he's not willing to say that. So he said, well, let's get some flaws. We have to work on it still. There's nothing to work on it. They're never going to work on it. No one's working on it because they can't work on it. You cannot explain absolutely anything with particles. And quantum is based on particles. So every time you introduce the particle hypothesis, meaning, which, by the way, is not a particle, but that's a second issue. But even if you did it with corpuscles, with classical particles, you cannot explain a single phenomenon in quantum mechanics, in the subatomic world. Not one. Listen what I'm saying. I want you to explain one. Find anything, anywhere on the planet, any mathematical physics that can explain one, just one, can give you a physical interpretation that is rational. I mean, entanglement, action at a distance, how does this particle affect that one? Tunneling, how does this particle go through the barrier and appear on the other side? It's all magic. It's more than magic, it's unimaginable. You know, particle at two places at once, what's there to imagine? How is that possible? What sense does it make? So the correct word is idiot. That's the word you got to use. When you refer to a mathematician, you got to use the word idiot. You got to call him an idiot, and then you're okay. Then you're fine. Don't say he's got flaws and that he's working on it and we don't know everything. That's idiocy. Okay, another issue. Okay, if I can get this thing in there. Okay, and perhaps one day we'll find the true physical interpretations that underlie our universe. But for now, it's exciting to experimentally verify. And in science, we don't verify anything. But he says, someday, some happy day, right? I'm going to do it by myself. That's how the song went, right? Well, here it is, okay? Here's my answer to this fellow. What will change in the next 400 years that hasn't changed in the last 400 years if the mathematicians, right, continue to be in charge of science? What are they going to do? Just descriptions for the next 400 years? Assuming we live that long. How can a mathematician ever provide a rational physical interpretation to a mechanism if he doesn't introduce objects, because he wants to mathematize everything, he just talks about equations, only does equations, and dismisses physical interpretations as philosophy. He says, oh, that's philosophy. We know it's irrational. So they know it's irrational. They can't give you a physical interpretation. They don't use objects, but you want them to give you a physical interpretation someday, some happy day. Experimental verify, that's known as religion. That only goes to believing, to your opinion, to change your opinion or to confirm your opinion. So anything related to the word verify, religion, has nothing to do with science whatsoever. We don't verify anything. Certainly, we don't use experiments in science. The only purpose of an experiment is to persuade the jury. The only purpose of evidence is to persuade the jury. Okay? So verify, you know, there you have the synonyms or what it means. Belief, opinion, experiment, proof, persuasion, convincing. All that stuff, none of that has anything to do with science. That has to do with religion. Anyone who does experiments is just trying to convince you of something. They're trying to persuade you, to try to change your mind or to confirm how you believe. That's it. It's got nothing to do with objectivity, with understanding a mechanism, which is what science and physics are all about. Okay, a fellow says, think the same fellow, says what? Says, Bill is not a scientist. In the scientific method, assumption, hypothesis, investigation, mechanism, conclusion, no mechanism or conclusion, no mechanism in all of mathematical physics, not a rational one, for the invisible, intangible stuff, okay? Mother Nature's invisible, intangible world, there is not one mechanism, not one, okay? But if you can come up with one mechanism, hey, great, I'll buy you a beer, okay? Retest assumption, retest for what? What are you going to retest it for? Until we can falsify the hypothesis. Well, in science we don't falsify, we don't do falsifications. That's people who are trying to, hit it big. They falsify documents, they falsify money, we don't falsify anybody in science, physics. And this fellow signs, Joe Sands, I worked with atomic force microscope. I use my atomic force microscope. I'm a scientist. He thinks he's a scientist because he uses a microscope. That's a lab boy. He thinks he sees himself as a scientist. I'm a deluded mathematician, he says. Well, yeah, that one I think he's probably right. Okay, I'll vouch for that. Yeah, if to you science is about describing, verifying, and falsifying, then yes, I do not fit that definition. Okay, your definition of science. And here's he continues with a scientific method here. If I can get this thing here. It says the essentials of science. This is according to him, right? The essentials of science are evidence. Okay, what gathered in experiments. What do you need evidence for? Evidence is used to persuade a jury. That's what you use evidence for. You don't use evidence in science. You use evidence in religion. Anyone introducing evidence is trying to persuade the jury. Theories about the evidence. Theories about the evidence? No, we need theories about a mechanism. Okay? And then the requirement that contradicting evidence falsify a theory. Okay, again, falsify a theory means that they convinced you otherwise. That's all that falsify means. So we don't present evidence, we don't do experiment, and we don't falsify theories, explanations. Okay? Whatever's false to you is true to your neighbor. So anyone using the word falsify, again, belongs to religion, not to science. Okay? However it is gathered, evidence must be unambiguous and repeatable, and it must be objective. I like this. He said, two impartial observers must come to the same conclusion. Okay, what if they don't? Okay, what if they don't come to the same conclusion? What should we do? Should we vote on it 50% plus one wins? Or worse, what if they both agree? And the two observers came to the conclusion that the world is flat. Okay, so we have the flat earthers, or the two came to the conclusion that Jesus went to heaven and came back after 3 days or whatever. What should we do? The two observers agreed. They're from the same congregation. So again, none of that has anything to do with science. It's got to do with religion, what this fellow is talking about. He thought he was a scientist because he runs in a microscope. My God, poor fellow. Okay, and one fellow says what? He says LHC creates LHC, the Large Hadron Collider in CERN, Geneva, Switzerland. I've been there, and it looks nice from the outside. LHC creates matter from colliding light based on E equals mc squared. People are so gullible. People are really gullible. Okay, so what does he say? He says, last year the Atlas experiment at the LHC observed 2 photons. This came from, I think, from the article that this fellow referenced. They observed, observed like with your eyesight, they observed 2 photons. Just zipping by them, 2 photons. You observe the photons, just going by. See, they use these words observed, and people swallow that like candy, They say, okay, they observed it. Who's going to question that if they observed it? What do you mean they observed? How can they observe 2 photons? What do they mean by observe? And that's what I'm going to get into, what they mean by observe, so that you see what that word means. how they cheat with that word, like they cheat with the word point and with the word circle. Here we have the word observed. Okay, let's see what observed means. They observed 2 photons, particles of light. So they observed 2 particles of light. Look at that. They got very good eyesight. Forget about, Superman. I mean, his X-ray vision, comes out of the eyes, goes through the walls. Ricocheting off one another and producing 2 new photons. So here they observed 2 photons. They collided, ricocheted one from the other, and they turned into what? They discovered where is it? And producing 2 new photons. Okay, so they bounced in to produce 2 new photons. Let's see how they did this. How did they observe? How did they prove this? All this evidence, all these experiments that belong to science, right? Let's see how they did all this stuff. I want to know. Okay. This year they've discovered photons merging and transforming into what? W bosons. And particles that carry the weak force. There you see the poor particle carrying the weak force, okay? Okay, what is this guy referring to? So I look up the article that he referenced, and let's go there. Let's find out what this is all about. 2 photons, and they turned them into 2 more photons, and they observed the photons whizzing by. Let's find out how they did all this. I really want to know. Science has advanced beyond my years. Okay, so you go and you find it here. This is the article he referenced. It's the magazine is known as Symmetry. It's run by what? Fermilab and SLAC. What is SLAC? Stanford Linear Accelerator. Okay, so these are big people. They receive government funds. That means your money. You're paying for this. Okay, and the article said a collision of light. A collision of light. They're gonna explain how light collided against light, what we call light on light. Okay, let's find out what these folks did, how they did their experiment, how they observed a photon hitting another photon. Now, I'm going to go slowly here so that you get the whole picture, okay, of how they did this, how they proved that a photon collided against another photon. Okay, so this is the starting point. Okay, keep track of this. Okay, for most of the year, the LHC collides protons. Okay, proton allegedly is a little ball that's in the center of the atom. Okay, fine. But for about a month each fall, the LHC switches things up and collides what? Photons maybe? Nah. They collide heavy atomic nuclei, such as lead ions. We're still talking about protons. In fact, here we're talking about protons and electrons. What they're saying is the ion, that the atom is ionized, meaning that it lost one of its outer electrons. Okay, but here they're going to collide what? First they collided protons, which are little balls in the center, and now they're going to collide what? Lead atoms. Okay, in other words, they ionize and that's what they're going to accelerate and collide. So far we have nothing about photons. That's the point I'm trying to make here. These ion runs also enable scientists to turn the LHC into what? A photon-photon collider. Whoa. Okay, so far we don't know how they did that. All we have is a statement, a claim, unjustified claim. Unsubstantiated claim. Let's find out. This result demonstrates that photons can scatter off each other and change each other's direction. That's what they're going to show with this experiment, that all these photons are bouncing off each other because what are they accelerating? Lead ions. Lead ions. Okay, that's all we have so far. So far they haven't justified the so-called photon. Okay, let's go to the page number 2. Really, it was in one article, small article. Okay, and so this is how they continue in their description. When heavy nuclei are accelerated in the LHC, they are encased within an electromagnetic aura generated by their large positive charges. Okay, yeah, whatever charges are. As the nuclei travel faster and faster, their surrounding fields are squished into disks, making them much more concentrated. Okay, so far again, we're talking about atoms and nuclei. Okay, we're talking about lead nuclei, in other words, lead ions. When 2 lead ions pass closely enough that their electromagnetic fields, a concept, right there, you see it at the bottom, swoosh through one another. So we have the fields now going through each other, whatever field is. Never saw a field swoosh through another one. Okay, they'd have to draw that so we know what a field is. The high energy photons, which ultimately make up these fields, can interact. So here we have a magnet, right? I would show my two little magnets. There they are. Okay, and you can see that they stick to one another. Okay. So they're saying that what's in here is photons. That's the field, the magnetic field of a atom, ion, right, is made of photons. That's what they're saying there. Okay, that's how they're going to turn this thing into, colliding photons. They're going to collide fields, and the fields are made of photons. That's their argument. Okay. In rare instances, a photon from one lead ion will merge with a photon from an oncoming lead ion, and they will ricochet in different directions. So now that we turn the field, which is made of photons, they say, we've never seen a field made of photons, but this is what they say, and now they simply state that these so-called photons, they bounce off each other. Okay, how does this thing end? Here it is. Find out how gullible these people are that believe all this nonsense. Sorry, I meant idiocy. However, according to Steinberg, one of the fellows that helped write this article, okay, or contributed, it's not as simple as two solid particles bouncing off each other. Oh, it's not. So it's not particles, which are not particles anyways in mathematical physics, especially in quantum. Light particles are both chargeless and massless, okay, and must go through a quantum mechanical loophole to interact with one another. Okay, let's look at this loophole. How do they do this? They have no way to bounce off each other without help. Oh, we need the servants now. We need the help, okay? When the two photons see each other inside the LHC, they sometimes overreact with excitement and split themselves into an electron and positron pair. Okay, so now the two photons each one turned into an electron-positron pair. Now we have four of these, four particles, two electrons, two positrons, right? These electron-positron pairs are not fully formed entities, okay, but rather unstable quantum fluctuations. They're just vibrations that scientists call what? Virtual particles. So now these particles appeared where? From the void, from nowhere, magical. God made them, just for the purposes of the experiment, right? The four virtual particles swirl into each other and recombine to form two new photons, which scatter off at weird angles into the detector. What are they saying? Let's illustrate this so that you get the picture. Here's the picture of what these people are saying. You can later read it more carefully. Here it is. Let's put it on this side. Okay. So this is what they're saying. You have two photons. They collide because what is colliding are really the fields, and the fields are made of photons according to these people. That means that a magnet attracts another by throwing photons, balls at each other, And these positrons and electrons recombine because they are virtual particles that come in out of nowhere. They recombine, they form the two photons, and each one of these photons then just goes off in two different directions and are captured by the detector. So this is how they said, they proved, this is how they observed through experiment. You got to do it through experiment. This is how they observed and proved through experiment that photons collide. The photons turn into virtual particles which recombine and create photons again. Great. That's the theory. That's their explanation. That's their physical interpretation. And gullible people like this individual here, he swallows this like candies. He drinks the Kool-Aid like you would believe. Okay, with that, I'm going to see you next time on Wednesday, and hopefully we have smarter people ask questions and all these bows.